Okay, so we're starting Unit 5. Unit 5 is all about exponential functions. So remember at the very beginning of the year when we talked about function families, and I think there were 5 function families. In Math 1, we are focusing on 2 of those function families in depth. The first one is the one we've been talking about basically all year, which was which function family? Linear function family. In Math 1, we're also talking about the exponential function family. The exponential function family, guys, the graph were the graphs that were shaped like those L's. So remember, they got infinitely close to the axis. So that was an exponential function, kind of what it looks like. They could have gone the other way as well, but that's kind of the basic. And then an example of a function family that is from the exponential function family could be y equals 2 to the power of x. So it's when x is in our exponent, okay? So that's what they look like. Today, we're just going to be introducing the idea of zeros and negative numbers in the exponent. So turn to that first page, 5-1. Since when you guys were introduced to exponents in 6th grade, you've only been working with positive, like x to the 2nd power, or x to the 3rd power, or you can calculate 5 to the 4th power. But we can also have negative numbers and zeros in the exponent. So we're going to talk about how that affects your exponent and what that does, okay? So the first thing we need to look at, there's only 2 pieces of notes that we have to kind of pay attention to. The first is that for every non-zero number a, we call that our base. So a is the base of the exponent, and it can be any number we want as long as it's not 0. A to the power of 0 is equal to 1. Basically, anything to the 0th power comes out to 1. The other piece of information you need to know is how we deal with negative exponents. So for every non-zero number a, that's your base, and an integer n, those will be numbers when we get to it. A to the negative n is equal to 1 over a to the n. In other words, when the exponent is negative, you raise the reciprocal of the base to the opposite of the exponent. Another way that I like to think about this, if a term has a negative exponent, it's like a big neon sign that's saying, I am in the wrong place. So we have to move it either up or down, depending on where it started, to the right place. Once we get that term to the correct place, the exponent becomes positive, because a positive exponent means it's in the correct place. So let's look at a couple examples. So looking down, a 3.9 to the power of 0 automatically comes out to 1. Anything to the 0th power is 1. With negative exponents, so part B, 9 to the negative 2. I don't like the way that this is written, so cross this out. Here's how I do these problems, because it makes a little bit more sense to me. 9 to the negative 2. Let's put that whole thing over 1 and make it a fraction. And this exponent of negative 2 is saying that my 9 is in the wrong place, so I move it down to the denominator. So in my numerator now, I don't have anything, so I put a placeholder of 1. And now 9 is in the correct place, so I make that exponent a positive exponent. So it becomes 1 over 9 to the 2nd. What is 9 to the 2nd, guys? 81. So the answer comes out to 1 over 81. So for the next example, I have terms that have positive exponents and terms that have negative exponents. So I only move the ones with the negatives. So in this one, 7b to the negative 3 all over a squared. Which term has a negative exponent? Let's think about it. What is that negative third attached to? Is it attached to the 7, or just the b, or all of it? It would only be all of it if there was a parentheses. It is only attached to the b. So circle b to the negative third, and what do we do because the exponent's negative? Bring it down. The 7 gets to stay because it has a positive exponent of 1. A to the second gets to stay because it has a positive exponent of 2. So to rewrite this, we write 7 over a squared b to the third, and that ends up being your answer. So you only move the ones with the negative exponents. Everything else stays. If there was a parenthesis around the 7b, then you would move the whole thing, okay? But you only move what the exponent is attached to. So on the next page, we're going to do these 4 together, and then I'm going to have you guys try some on your own, and you can work with your neighbors. 2a to the negative 5, which, first of all, before we even start, I'm going to put the whole thing over 1. So I want to make it a fraction. Which term has the negative exponent? Just the a. So I circle a to the negative 5, and that means I'm going to move it down. So on top, I still have 2 over 1 times a to the 5th, so I'm just going to write it as a to the 5th. And that's your answer. So since I moved it down to where it belongs, that exponent now becomes positive. If there was a number here and you actually could do it, like 2 to the 5th, do it. Okay, don't leave it as 2 to the 5th. Write it all out, okay? Number 8, negative 7 over 8, all of that to the negative 2. So what actually is being raised to the negative 2 power? Yeah, the whole thing, right? So another way of talking about the negative exponents was that we take the reciprocal. So what do you guys think we're going to do here? We're just going to flip the whole thing. So it becomes negative 8 over 7. And now everything is in the right place. So it's to the positive 2 power. Okay? Because this is saying negative 7 is in the wrong place and 8 is in the wrong place. So we just flip it. Now, can I do this? What's negative 8 over 7 squared? That's negative 8 over 7 times negative 8 over 7. Which comes out to positive 64 over 49. Leave it like that. Okay. If you can reduce it, reduce it. This one does not. Please do not give your answer as a decimal. Just leave it like this. Okay. So that's all you have to do. Number 12. Negative 2r s to the negative 5. Which term, first of all, let's put the whole thing over 1. Which term has a negative exponent? Just the s. What about that negative 2? No, it's just a negative 2. Only when the exponent is negative do we move it. So that negative 2r stays on top, and we move s to the negative 5 down. So that's going to give me negative 2r over s to the 5th power. Make sure your s and your 5 don't look like the same thing. Okay. So number 16, 2 to the negative 3rd over m to the 0, n to the negative 1. What has a negative exponent? N and 2. So I'm going to move that 2 down. And what am I going to do with the n? Move it up. So that's why I like to do the arrows. So it helps me visualize moving it. So what's going to be on top? N to the 1 over 2 to the 3rd, m to the 0. Now there's going to be one more step in simplifying this. N to the power of 1. That just is what? That's just n. So you can write it as just n. Over. What's 2 to the 3rd come out to, guys? 8. 8. 2 times 2 times 2 is 8. And m to the 0 is 1. No, 1. So 8 times 1 just gives me 8. So your answer simplifies to n over 8.